Where's Slack? Hold on one second. Okay. Winnie, queuing you up. What is testing and why is testing important? By the way, Eric, I never said that. Come on. Okay. What is testing? Why is it important? Testing looks for edge case bugs. Yes. It's a way that it kind of forces us to think about making sure we've solved for those strange edge cases. So we all know that a lot of our users are not really going to use our software exactly how we think they will. So we have to solve for those edge cases for the way that they're actually going to use our software and run into bugs. Checks for flaws and user interface issues before launch. Checks that our functions are behaving as expected. Save time on debugging. Yes, this is a big, important one. Testing is validating our code's behavior. I like that, Dave. We do it to confirm our code does what we expect it to do in lots of different situations, including those edge cases. Checks for bugs, find bugs faster. That's important. If we can find those bugs faster, then we will have less of those in production and less headache later. Make sure we're interacting well with the DOM. Check for bugs, ensure your application works. Quality code. I like it. Cool. Let's see. Wow, lots of great answers. Dang, I wish I had time to go through all of these. And yeah, this is good. This testing saves your company a lot of money from the time lost trying to debug the code after it's written and after you've pushed it to production and users are complaining that it broke somehow. But what about maintaining code? How does testing help us when we're coming back and working on something that's already been built? What if we have to change a component that's already been built? How can testing help us? You can stay in the same thread here. Makes it less scary. Yeah. I'm going to touch on this in just a second because that's absolutely perfect. This is really good, Brittany. It acts as documentation. Make sure the new parts don't break the old parts. So yeah, if we have tests, we often, in our tests, you can go to well-written tests and know, get an idea of the different edge cases, get an idea of what a component needs in order to work. So yeah, it does. That's really good. It acts as documentation there. Systematic refactoring. I like it. Make sure integration is optimized. If something gets messed up, you can see where things go on. Perfect. Yeah. So let's say you've built a component already. You've written good tests for it. And then 6 months later, you come back to change that feature a little bit. Change that component. Maybe you want to add something, change something. As you are working in that component, your tests will tell you when if you've introduced a new bug. So your tests will start to fail if you do something wrong. Yeah, to make sure it's still working, use the test to make sure it's still working. Nice. Oh, I like this, Kevin. Reminds you what the code did. So kind of like Brittany was saying about documenting your code. Yeah. Oh, don't we all? All right, I want to go back to what Christine said here. Makes it less scary. So one thing you'll hear a lot and read a lot when it comes to testing, is that testing gives us confidence in our code. So last question here on this thread, what does it mean to be confident, to have confidence in your code? Yeah, you know that the code is doing exactly what it was intended to do. You have confidence that it's going to do what you intend it to do, that it works in a lot of different situations and cases, that it's efficient. When it fails at demo, it's not your fault. Yes. If another developer, oh, this is a really good one. If another developer were to modify your code, you have confidence they won't break it. They'll see the broken test and they'll say, oh, I have to solve for this edge case. Thanks for writing that awesome test, Dominique. That's why we hired you. You understand what each part of your code does and where it fits in your app. Not having to say, my code works and I don't know why. Yeah, it leaves back to that documentation idea. Knowing that it will work when a user actually uses your application because you tested it. So you have confidence that in production, it's actually going to work. What is Josh Zeger doing here? Are you here, Josh? Or do we have another Josh Zeger in class? Nope. I saw Josh Zeger writing down here. He's an old SL. He's on the student success team now. It was just typing a message. Yeah, good for collaboration. Awesome. Okay, so really, really great answers here. Thank you very much. Everybody that answered gets 15 points for your Hogwarts House of Choice. Woo! I had one student that was really close to finishing an app that would keep track of points for each house. And so if I tell you that you get X amount of points for your Hogwarts House of Choice, you could go into the app and add 15 points or whatever. And then at the end of the cohort, we could see which house wins. But I haven't heard from, I don't know if they ever finished that. So if someone wants to build one, feel free. All right. So let's do this. We know what testing is, or we know why we have testing. We know what the principle of testing is. We just don't know how to implement it, what it looks like in code. So let's go ahead and let's build some tests. Let's see what it looks like in code. And we're going to start from the very basic. We're actually going to start not with Jest, not with React Testing Library. We're going to start from the very basics, building our own testing library. Yeah, we can do that. So to start out, I want you to find a place to build a new JavaScript file. Okay, so I'm going to say, let me cd out of here and make a directory. Actually, build a folder. Let's call this, well, I already have a folder called testing, so name the folder whatever you want. I'm going to say testing. Whoa. That was my computer freaking out again. Oh, I should just leave it. There we go. Okay. Now inside this folder, we're going to create a file called testing.js. And then we're going to open this up in your, oh, why didn't that work? In the code editor of your choice. There we go. All right, perfect. So we've got our testing.js file here that we're going to be working in today. So we're going to start with some very basic tests that we call unit tests. Unit tests test a single unit of code in isolation. So if we can isolate a single unit of code, usually a function, then we can test that code in a unit test. And we can test it with different use cases and make sure that we're covering different use cases for that unit. All right, so that means that we need to have some units to test, right? So let's create another file here. We're going to call this math.js. Learning testing is a lot easier with math functions because they're easy to implement and test different situations. Okay, so we're going to create a sum function, and this is going to take in two numbers, A and B, and we're going to return the sum of these two numbers. By the way, arrow functions work as one-line functions like this because if you don't have brackets right after the arrow, then whatever comes after the arrow is implicitly returned. So we don't have to have the return keyword here to say return A plus B. That is implicit in the fact that we don't have brackets surrounding the code after our arrow function. So this would be the same as doing this. So this is the same exact function. This is just written in one line with an implicit return rather than using brackets and the return keyword. So you can take away the return keyword, take away the brackets, and there we go. We've got the same exact function. Let's keep this line here. So go ahead and copy and paste that line. And we're going to create a diff function. Let's call this subtract. Okay, so we've got our two mathematical functions here. These are what we would consider these two functions can be considered units. They are isolated and easy to test. So if you can ever abstract logic like this out into its own isolated function, it becomes a lot easier to test in a unit test. All right, we're actually going to be using Node. Haha, you get a quick introduction to Node. And the way Node works for exporting and importing is a little bit different. So just stick with me. We're not going to be doing this in your project tonight or today. You're not going to be doing this on in the challenge tomorrow, anything like that. Just stick with me while we do this during our guided project. So we're going to say module.exports. This is the way to export modules in Node. So modules.exports is an object, and you just pass in the modules you want to export. Subtract. Okay, so let me give you this whole line here. So there you go. You've got that file. You've got the module.exports line. I am operating off of the assumption that you have Node installed. I don't know if that's actually true. So if you go to Node, to your command line, and say node-v, you should get something like this. If it comes up with something like this, command not found Node, then you don't have Node installed. I think you all should because you're using npm and all that, but just in case, if this happens, then you'll probably just have to watch and install Node later. All right, so let's go to our testing.js file. And we're going to write a very basic test function for our math problems here. In order to do that, we have to understand what a JavaScript test even is. So a JavaScript test is basically code. A test is code that throws an error and the actual result of something does not match the expected result. And this is what a JavaScript test, this is what any kind of software test is, down to its very basic form. It's just some code that throws an error when the actual result of something doesn't match what we expect it to. All right, so we can use that. We can work off of that to build a test. So we're going to import our two modules. So we're going to say const sum and subtract. Now we're going to use the require keyword in Node. And we're going to require this from our math file. Hey, you just wrote your first lines of Node. Yay! Round of applause for yourselves. Woo! Okay, so this is just importing and exporting. That's how we do this in Node. So don't get hung up on that. You're never going to use this again until you get to the backend unit, if you choose to go through the Node unit. You won't use this anymore in this unit at all. Okay, so let's do this. We want to run these functions, and we want to see if the actual result of running these two functions matches some kind of expected result. So usually what we do is we set up some variables. So we're going to say let's call it let actual. We're going to leave that blank. And let expected, we're going to leave that blank. And we're going to say, we're going to run our function, and we're going to set the value of actual to the result of our function. So let's start with sum. We're going to say result, oh sorry, not result, actual. So the actual outcome of some, let's say 2 and 2 is going to be, when we add, when we add 2 and 2 together, we're going to get 4. So actual right now is going to be set to the number 4. And let's say, so let's set expected. We expect the result of this to be 4. So now we just need to throw a code or throw an error if this doesn't work. So we're going to say if actual does not equal expected, we're going to throw a new error. And the error string we're going to throw is going to be an interpolated string, so we can put our variables in here. So we're going to say actual. So what the code actually returned is not equal to what we expect it to return. Uh-oh. Expected. All right, pretty straightforward, right? This is a legitimate JavaScript test. It's a piece of code that throws an error if the actual result of something does not equal what we expect it to write. So this is going to pass our test. We're not going to see this error because actual is going to equal expected. So let's try this out real quick. We're going to run this code with Node, and we're going to make sure that we don't get this error. And then we're going to do what's called a sanity check. So I'll talk about that in just a second. All right, so testing lect. What you're going to do to run this code is say node, and then testing.js. All right, I ran my code. No error, so that means my test passed. Yay, we have our first passing test. But that's not good, right? We want to, you actually want to see your tests fail as a sanity check. You want to make sure that everything is implemented, your testing are implemented correctly. So let's go back to math, and let's change sum to minus. This is called a sanity check. You're just going to make sure that the test is actually working as you expect. So we're going to run our test again. Aha, see? Oh, it's because I didn't save the file. Now let's try it. There we go. There we go. Error, 0 is not equal to 4. So sanity check, we know that our test is running and is running correctly. So we can change this back to plus, run our test again. And now after that sanity check, we know that our test is actually running and working. Okay, one last thing before we look at questions and take a quick break. Does anybody see any problem with this test? Is there an edge case that would make this test fail? Or is there an edge case that not would make it fail, but something that we need to test for? Ooh, yeah, we would want to test for non-number params, extra arguments. We do want to test subtracting. Yeah, these are all really good edge cases, and those are things we want. We want to that we want to test for. What I'm thinking about is, what if, is there a way that passing 2 and 2 and getting 4 out of it would pass a test even if some were implemented incorrectly? What other mathematical function gives us 4 if 2 and 2 are passed into it? Yes, yes, awesome. So let's go back to math and let's say times. Let's say we accidentally did times instead of plus. And then the only test we wrote for sum was 2 and 2. Let's run our test. Test is passing, yay! Except not yay, because it's not gonna pass if we do something else, right? So we're gonna copy all of this code. Excuse me. And we're gonna pass in a different set of numbers here. So we're gonna say 3 and, I don't know, 7. We expect this to equal 10. Save that, run our tests. 3 times 7 does not equal 3 plus 7. So now we go say, oh, whoops, we did multiplication. We meant to do addition. Fix it, run our tests, and it works. So a couple principles here. This part of our code, this is called an assertion. This is asserting that what is actually being returned here is what we expect it to. So this part of our code is called an assertion. So we're going to write multiple assertions to check different use cases, edge cases, use cases, make sure that it's actually working. This is another sanity check here to make sure that if you just test with one case, that doesn't really give you full confidence in your code. Now that I've checked 2 cases with different expected expectations here, now I feel a lot more confident that sum is really doing what I expect it to do. Now you could say that you could just have this test and that should be good enough for sum. And yeah, I think that's a good argument, but I still think that writing multiple assertions really gives you more confidence in your code. All right, let's take a look at questions. All right, so if testing is its own thing, why do we console log so much in JavaScript? That's a great question. So we'll get to this in a minute, but we're actually going to be doing automated testing. Console logging helps you in your workflow. So you could avoid a lot of console logs if you follow what's called TDD, test-driven development, where you write your tests first and then you implement your code. The reason we do a lot of console logging and debugging while we're writing our code is because we have to get it working first, right? So if you write your code first and then do your tests later, then you have to have some way to test your code, right? So we do console logs. That just helps our workflow. And you can look up test-driven development, and there's a lot of people that really preach that that's the best way to write code, is write your test and expectations first, and then write the functionality to match your test cases. Then you don't have to do this as much because your tests now become your console logs. What about errors that show up sometimes when we do our projects? I mean, that's just learning. That's just part of learning. You're going to constantly run into errors. There will come a point where you will, through a lot of experience, you will be able to foresee errors that are gonna error. You'll be able to see the errors come up and know that they're going to happen before you write your code, and solve for those errors so that they don't ever happen. Not every single error, but you will see the roadblocks before you implement your code and the possible gotchas, because you've have the experience. That usually takes quite a few years. So there will come a point that you don't have the errors that show up. But until then, it's just part of learning. You don't know, you can't predict the errors if you've never seen them before, right? So yeah, this is all just part of learning and becoming better and better. When we're setting params, when would it not be beneficial to use so this is kind of a specific edge case type question. I'm not really sure what, without more context, what you mean. I hardly ever do this. I mean, it's up to you how you want to set up functions. If you would rather your parameters be spread into an object, this is more kind of a up to you type detail for how you program. Is testing this way different than testing with a try-catch block? Yeah, so what we're doing is we're writing these tests here manually, and these are ones that we could write in all of our code, but we're actually going to see that there are some ways to automate all of this so that we don't have to be doing things like throwing errors every single time we write a function. I mean, you still want to throw errors and solve for that in your code, but I mean specifically for testing. So yes, testing is different than writing try-catch blocks in your code. You still want that in your JavaScript files. In our test files, we're going to be focusing on automated testing. So we'll come back to that after this break, actually. After this break. At what point does sussing out extreme edge cases become less important than just assuming it works? Are there in-house developers that specialize in writing tests to find edge cases that a junior dev might not consider? Yeah, there's some people that focus on this too much, extreme edge cases, and think that it's more important to have so many tests that there's absolutely no way anything can fail. And if anybody ever works in that component again, they will for sure, they'll have to write it to get every hundreds of tests that you wrote to pass, just to make sure that every single edge case is covered. That actually makes, there's a trade-off there. That's good, right? Because then you don't ever see bugs, but you can't move forward very quickly. So you can't maintain that code very well. It takes a lot more work to maintain that code. So there's a trade-off between having total 100% code coverage on your tests versus being able to roll out new features, update things, maintain your code in a reasonable way. So yeah, absolutely. There's definitely a point that this becomes less important. And again, testing is, there's so many different situations for testing. Different opinions that's really going to come through experience. There's not a single answer to that one point that it becomes too much. That's something that is up to you and your team. And yeah, they're definitely in-house developers. They're QA engineers. So you have QA testers that open up your software, click around, and say, oh, hey, this is working. I don't know why. I can't go into the code and fix it. But by the way, this edge case doesn't work. And they provide you with the specific environment, what they were doing, what they typed into, what buttons they clicked, all of that. So QA testers are great resources to have. They get into your software and try and break it in the browser. QA engineers are hired usually in bigger companies to write the tests for you. So it depends on the company. You may have QA engineers, you may not. So yeah, it just depends. If you don't, then as a junior dev, you'll just have to go through experience. You'll build a feature, and then a couple weeks later, you'll find out that it's breaking for users, and you'll say, oh, I didn't even think about that edge case. But next time you build a similar feature, you'll remember that, and you'll test for it, and you'll solve it. And that's just how we learn. That's how we grow. That's exactly what companies expect. Awesome questions. Let's take a quick break, and I'll see you back in 5. All right, come on back to your computers. All right, so for this next part, I want you to work on part of this on your own for a couple minutes here. So we'll do this for about 2 or 3 minutes. What I want you to do is write a test or some tests for the subtract function. Probably write 2 tests. Let's just make it official. I want you to write 2 tests for the subtract function. You can keep the actual and expected. So the reason that we started these variables with let is so that they can change as the node engine goes line by line and reads our code, right? So we first set actual here, then we change actual here, we set expected here, we change it here, so that we can run each of these 2 tests. So I want you to, you'll basically have to write, use these 5 lines of code to write 2 different tests for the subtract function. After you write your tests, then you will go into your terminal and run node testing.js. Part of this too is you'll want to change your subtract function, maybe to add the numbers together instead of subtract, so that you see your tests fail and you know that your test software is running and working. That's what we call a sanity check. So you do want to see your tests fail, especially if it's controlled and you know why they're failing. That helps us know that the testing software is actually running. That's what we call a sanity check. Okay, so 2 minutes, ready, go. Okay, who would like to share your solution, your tests here? Let's do this on the thread. Oh, there's different colors. Thread red. Share your tests. Ha, beat you, Winnie. Woo! It is a race. Oh, we're getting fancy here. We have an assert function. Haha, that's really cool. Good job, Joe. This was about what I had asked for here. So actual, we run subtract, and we expect that to equal 12. So we pass in 12, and then throw the error if it doesn't work. Great. Then we have 7 and 3 should equal 4, and run that. Nice. Testing for not a number. Nice. Testing some edge cases here. That's really cool. Good job. Great. Yeah, great work. 30 points for your Hogwarts house of choice. I'm like throwing out points. I must be in a really good mood or something today. You guys are getting a lot of points. This is great work. I love it. Let's see. Let's go with Amberly's here. Okay. So we've got our actual is 10 and 7. We expect that to equal 3. And then we throw our error. 20 and 10 should equal 10. So yeah, this should pass all our tests, right? And it does. We'll do a quick sanity check to make sure that our tests are actually running as we expect them to. Boom, perfect. Okay, love it. Great work. All right, but as I said, this would get we don't want to write tests this way. So I just made you write it the way we don't want to write it. What we want to do is we want to automate these. We want to be able to use some software that we can start up our testing and be testing as we're building. We also want to make it a little bit easier on ourselves by doing things like Joe did here. So actually, so Joe built an assert function that takes in an actual and expected, and basically said, does our assertion inside here with our console log. So let's go look at this. Let's put this in our code. And I'm going to save that, and I'm going to run here. Nice. So if it doesn't equal that, then we throw an error. Otherwise, we console log that our test is actually passing. Really cool to have this assert function here. And then we can just run our assertions inside that function. Did you know that that this is actually built into Node? Aha. So let's do this. Let's create a new file. We're going to call this testing. Hey, come here. There we go. Testing2.js. And we're going to grab assert. Joe, that was a perfect segue. Thank you very much. So we're going to grab assert from require assert. So this is built into Node. Pretty cool. And then we need to grab our functions, sum and subtract from the math file. Then we're going to kind of do the same thing we did before. So actual, let expected But instead, this time we're going to do something kind of similar to what Joe did here. We're going to run the assert function and pass in our actual and our expected. So we're going to say result equals sum 3 and 7 expected equals 10. Then we're going to call assert and pass, and we're going to say assert has some methods on it. It's not a function, it's an object with methods. So we're going to say assert, we're going to say strict equal. So we want these two, our actual and our expected, to strictly equal each other. So we're going to say 3 and 7. We're going to say result. Why do I keep saying result? Actual and expected. So this will tell us if they strictly equal each other. So let's save that file. I'll give you all of this code. Oh, I spelled it wrong. Subtract. Thank you. So there's all that code minus the act. There we go. So that's what we want testing2.js to look like. All right, let's go ahead and open up our terminal. We're going to say node testing-2.js. Hey, everything passed. Sanity check. Let's make it break first. See what that does with this assert library. Ah, here we go. -4 does not equal 10. Good. Good, good, good. So save all of our files and go back. Good. We'll do the same thing with subtract. So subtract 10 and 7. Yes, we usually want to write more assertions, but due to time constraints, we're going to push through this here. We expect this to equal 3. And we're going to assert strict equal, pass in actual and expected. Good. So that passes our test. Now, one problem we have with this is tests are really only as good as the errors messages that they throw when they fail. So what if I do this? What if I say, change this, and I have a failing test? Well, I don't really know where this it takes me a little bit here to figure out where this test failed. Okay, I don't know which test this is testing. I'd have to, usually I have a lot more tests, and so it'll take some digging around. Maybe I have to come here and see, look at the line numbers and find the right line. This is a little bit tougher to see which of my tests is failing. So because of that, we're going to write a function to help us out here. We're going to say const expect. It's going to be a function, and it's going to take in the actual and it's going to return an object. So this object is going to have a method, a function on it called doB. And this function here is going to take in an expected param. Again, these these are parameters. We could name these whatever we want, okay? Inside here, these are not referring to our variables up here, just so you know. So we've got a function called to be on this expect function. So when we call this function and pass in an actual argument, it's going to return it's going to return an object with a to be function on it. And then this is where we're going to do the same assertion that we had here. So we're going to say if actual does not equal expected, then we're going to throw our own error. So let's do this. We're going to go ahead and, well, we'll keep those there. Let's just use this now to say, let's bring these down. We're going to say expect. We pass in our actual. That returns an object with a to be function, which is a function here, right? So we can call expect and pass in an actual, which gives us an object with a method on it. So we can call the method off of this function call. We're going to pass in our expected. And now if our sum function fails, let's comment these tests out here. So now if our function here fails, if our test fails, then we get, oh, that's not a very good message yet, right? So let's see what we can do to write a better error message here. Grabbing. Okay, there we go. So this is our own, we basically wrote our own assertion library here. We're passing in our actual, our expected. We're getting the error thrown if our actual and expected are not equal to each other. But again, we don't know which test is failing. So we're going to write one more function here called test. And this is going to help us run our actual tests here. So this function will take in a title and a callback function. And we're going to wrap, let's see. I don't know if you've worked in try-catch blocks before. So let me just write out this function, demonstrate what this does, and then we'll move into Jest, which gives us all of this, all of these functions for us. So this exercise is just letting us see under the hood how these different functions are working that we're going to be using in our tests. So if you haven't done try-catch blocks before, this is a good introduction to it. Basically what it says is we're going to try this code here. And while we're trying this code, we're going to say console log. If this code works, then it'll move on to this line. And we're going to console log something. If this code doesn't work, then it's going to catch an error. And we can console, this is a cool trick, console.error, something down here. So this just brings up the red in our console log. All right. Again, don't worry too much about any of this. You don't have to write things this way. This is just so you can see under the hood what's happening. And then in just a second, we're going to see, we're going to use Jest, a testing library that has all of this built out for us. So let's do this. We're going to call our callback, which will have our tests inside of it. If our test fails, if it gets an error thrown, then we're going to jump into this catch block. If it doesn't, then that means that our test passed. So we're going to say, let's find a check mark here. So if we hit this line of code, again, it means that there was no error thrown in our callback and our tests pass. So we're going to say check, and we're going to console log the title of the test that passed. But again, if that test didn't pass and it throws this error, that error, this error message here, gets caught by this catcher. So this string right here will be passed to the catch block as the error. And we're going to say two things. We're going to console.error, and we want, where's the red X? Is there not a red X? Let's see. Let's just do something red. Let's do broken heart. And we'll say title. And then we're going to console.error the actual error message here. So what this function is going to do is it's going to help us, as we're writing our tests, see which tests are actually failing. So that means that every time we do a test now, we're going to wrap that test inside a test function. So we're going to call test. We need to pass in a title, so we're going to say sum returns the sum of two numbers. Okay, so we've got our title. We're going to pass our callback function in, and we're just going to nest everything here inside our callback function. So what's going to happen is when I run this node file, it's going to run test, and it's going to take in a title and this callback function. Then we're going to try this code, and if any error is thrown in this code, then we're going to jump to the catch, and we're going to console.error these two things. But if there's no error thrown, then that means we're good to move on to this next line and run this line of code. So when we call this callback, that's when we set up our actual, our expected. We run the expect function, and inside this is the expect and the to be function. If they're not equal, then we're going to throw the error. So while we're running our callback function here, if this throws this error, we won't see this check mark console log. We'll jump into our try catch block, our catch block. So let's test it out. I think math is still wrong, so we're going to see this fail first. Ah, there we go. We failed our test. We see that the sum returns the sum of two numbers is broken, and then we see how it's broken. So this helps us, again, see what exactly is broken here. So if we do this same thing for our subtract returns the difference of two given numbers. We do our callback function. We set up our actual. We'll say 10 and 7. We'll do our expected. We expect that to equal 3. And then we'll use our expect. We expect our actual dot to be our expected. So now let's go run this. Now that we have 2 tests, it's helpful to see that sum returns the sum of 2 numbers is broken, but subtract returns the difference of 2 given numbers is working. Again, this part of our code you don't need to write. This is what's happening under the hood in Jest. This right here is exactly what our tests are going to look like. Pretty fun that we can implement these libraries in just a few lines of code, right? Like we literally just built a part of the Jest testing library right here. Okay, let's make this pass again, and then we'll take a look at some questions. We've got a little extra time for questions on this round. So if you've got any questions on this, we can take a look. All right, yay, they're both passing. All green is good, especially after we've done our sanity checks to make sure it's running correctly. Okay, whew. Lots of cool stuff today. Can you explain what those 2 emojis mean, the use of check and heart? I don't understand. Yeah, the 2 emojis are basically telling us if our test passed or if it failed. So when our test is failing, if we have a failing test here, so now our sum returns the sum of 2 numbers. It doesn't. It returns the difference of 2 numbers. So broken heart, usually this is an X, a red X, not a broken heart. This just tells us that our test is broken or our test is failing. So this signifies a failing test. The green check mark signifies a passing test. And that works because of our try-catch block. Again, if this is confusing, don't even worry about it. Just push this out of your mind and focus on this part down here, okay? Okay, so here's a question that came in. I keep getting this error. So I have the same code written out in testing2.js. Type error callback is not a function. You need to make sure that, so callback is referring to this right here in your test. So whenever you write out your test, and this is exactly how it's going to be in Jest, you're going to call this function, you're going to pass in some title, and you're going to pass in a callback function. So you could keep this at the top of your code and copy and paste it every time you want to write a new test and say test goes here, and then don't forget to add in your title. So what you are running into is that the second argument, callback, is not a function. So you need to make sure to pass in an anonymous arrow function there. All right, we don't need to set up the test function? Correct. Do we have to import it? No. This is the cool thing about Jest. Test actually becomes a global variable when you are using Jest. So we'll see that in just a second. You don't have to import it. You don't have to do anything. Literally in your test files, all you have to do is run test, pass in a string, pass in a callback function, and run your assertions. So yeah, super cool. We're going to see that right after this break. So let's take a break, and we'll implement Jest, and then we will talk about React testing library. So I'll see you back in 5 minutes. Okay, here we go. Last bit of this. Oh, thank you, everybody. I was just going to do that. Awesome. A couple things I want to, or one thing I want to address real quick. Corey, thank you for bringing this up. Great point. What about that describe function that we see in Training Kit? So there are different ways to write this test. There is a describe function that does the same thing as test. And then if you use describe, then you implement an it with a title and a callback function as well. But since the time that Training Kit was written, we need to update it a little bit because this is kind of going out of practice. More people are using just the non-nested test function. So you can basically take any it function inside your describe and pull that out and pull all of that, the title and the code inside it, and put it into a test so that it's not nested. There's some reasons for that. Mostly it's easier to read. It's a little bit more verbose this way, but it's easier to read than having a bunch of nested tests. What happens is inside your describe, before you do any of your tests, there's usually a lot of variable, and before test, which is another function, setup. And so if you're doing all of this inside your describe and then you have 10 nested tests, it's hard to go back and forth and see what all this setup is when your tests are nested. So inside our test, we do the setup every single time. Every single time we run a test here. So it just helps us keep everything right in one place so we can see it, even though we are repeating code quite a bit in tests. So dry isn't as much of a principle in testing. But the reason for that is so that we can really see, we can keep each of our test cases isolated and see what the variable is, what the setup is, why this test is failing. If it were different, then our tests go in here. And let's say we had a ton of nested it tests, and these would be even longer because there'd be multiple lines inside here. Let's say this test was failing. We'd have to come up here. We'd have to see what our variables and setup were, come back down here, look at our test, come back up here. It's just mostly for maintainability. So great question. You're welcome to use describe and it like this. I'll leave it in here so you can see the setup again. But I would highly recommend going with the test function and not nesting all of your functions. Okay, cool. Let's make sure math is set up correctly. Oops, oh, that's okay. Make sure that we are now passing our test. I'm so sorry, this should have been a lot bigger. I really apologize, I didn't make that bigger. There we go, we are now passing our tests. Okay, real fast, I will drop this. Development, Lambda. And let's go to Slack. Here is the testing folder that we've built so far today. So there you go. Now we're going to jump into Code Sandbox. And we're going to cover React Testing Library. And React Testing Library comes with Jest built in. So if we were to work in this file, this folder here, still, we would, let me get iTerm, there we go. We would want to yarn add a dev dependency of Jest. Let it run its thing. You don't have to do this when you're in React. In fact, if you install Jest into a React project and React Testing Library, it will throw an error. So don't add both Jest and React Testing Library. Okay, so this gives us a dev dependency of Jest. We've got our node module. We can now take away these. I actually didn't try this yet, so I'm hoping we can do this. It didn't catch. Okay, there we go. We can take away those, and we should still be able to run. Oh, it's already added. I want that one. Nope, test is not defined. Okay, that's okay. We haven't set up the rest of our dependencies here. You don't need to know how to do that. I was hoping that would work, but it doesn't. So I'll show you how to do it in React instead. All right, so we're going to pull up. I'm going to scroll way down to the beginning of time. Let's see. You know what? Let's go to GitHub. And I want scoreboard. Remember this project? This was a fun one, right? I think this is the very first React project, right? So I'm going to grab this. I'm going to create a new code sandbox by importing this from GitHub. I don't know if you know you could do that. It's super cool that you can. Okay. So I will give you, let me make a change and save it. Nope. Does it fork? Yeah, it does fork. There we go. Here is the code sandbox we'll be working off of today. Yeah, I'll go over that in just a second. Oh, yeah, let's try running Jest. Jest. Yeah, I'm not gonna worry about it since we're not using that anyways. Okay, so here is our code sandbox. Jest does come with Create React App. That's what Samuel's referring to here, what I just talked about. So in a React project, do not, if you're going to install React Testing Library, do not install Jest. So actually, I think it comes with React Testing Library, not Create React App. But we can check real quick. Node modules. Oh, it doesn't have our node modules. Okay, someone find out for me if Jest comes with Create React App. I know for a fact that it comes with React Testing Library. So as we add the dependency at testing-library /React, as we add that, it will bring Jest in for us. And if you install both React Testing Library and Jest, it will break. So yarn add -d and or npm install, I think it's the same, capital D, not sure. Okay, cool. So you don't need, again, you do not need Jest if you do this. In fact, it will cause an error if you install testing library, React testing library, and Jest. So don't do both. Okay, cool. So let's see what we want to do. I'm going to open this up in a new window. And we've got this scoreboard that lets us, should be, I did the wrong one. Let's see. Sorry, I thought I had a code sandbox ready for this, and I did not. Hold on one second. I apologize. I think this has the solution in it, though. Oh, no, we're good. Okay, yes, we're good. We're good. We're good. Okay. So this is the one we want to work off of. So ignore this one. Just going to delete my message. This is the code sandbox we want to be working off of. And we're going to open this one up in a browser. We can see that we can run all of our buttons here and increment the score. Lines are totally destroying the tigers. All right. So instead of, Code Sandbox is really cool because it has a built-in test runner. Just like React testing library, just like Jest does inside Node, this will run our tests right here. So let's go ahead and close that down for a second. We'll come back and look at the tests. Now, this is set up a little bit differently than the where you had it on the first day. So what I've done is oh nope, this is the same. Okay, we haven't set this up yet. All right, cool. So React Testing Library. To understand React Testing Library, what we first want to do is understand a little bit more about Jest. So Jest, we saw that we can test our functions with these assertion helper functions here. So with expect and to be, we can assert that our actual result is our expected result. So if you go to Jest and we look up Jest assertions, then we can see all the different assertion functions that Jest has built into it. So we've got, if we go down to expect, here we go. I'm sorry, this is not what I wanted, Jest assertions. Here we go. Here we go, this is what we want. Okay, let me give you this link. All right, so these are all the assertions we can make from the expect function. We can call, we'll see that there's to be. You can call expect dot to be. You can call not. You can pass in a function and assert that that function has been called. You can see how many times the function has been called. There's a whole bunch of assertions you can make: to be null, to be truthy, to be undefined, to be nan. We saw someone write the edge case for not a number, right? So you can check an edge case to see if our sum function returns a non-number. A whole lot of assertions we can make. The reason there's so many assertions is, again, there's so many different situations with testing that you might want to test at some point in your life. So we have all of these assertions. There's a whole bunch of functions we can run to help us make our assertions. Now, similar to that, we have React-Testing-Library that helps us do the same thing in React apps. So we're going to go to this cheat sheet, and I'll give you this link as well. And what this does is it gives us queries that are similar to these assertion helpers here. So when we make an assertion in React, the most basic type of assertion we could make is an element found in on the DOM when our app is built in the DOM. So for example, this Lions scoreboard here. So let's go write a test to see if we have the Lions element and the Tigers element. So this is what a unit test looks like in React. All right, first of all, we have our app.test.js. This is rendering our document with React DOM.render. And we're just making sure, we're just asserting that this doesn't throw an error. So this is always really good to have, but it's a little bit verbose, right? So these render functions are actually given to us by React Testing Library to make it a lot easier to read. So let's go look at React Testing Library. We're going to go look at an example. So we're going to, in our test file, we're going to look for import React from React. And then from React Testing Library, we're going to import the render function. We don't need the React DOM function here. We're going to do our render with React Testing Library. So let's remove React DOM. We're going to say import render from @testing library. Oh, we haven't added it into this project. @testing library / React. Okay, now we can import this. So that means we can remove these, and we can just assert that our div is going to render. So let's go look at how we render our div without the React DOM render function. This is a more complicated example, so we're just going to take pieces of this. So the piece we want is this right here. We just call render, and we pass in any component that we want to test that it's rendering. So that's fun. I hope I saved my file. We'll see in a second here. There we go. Okay. And we're back. Good. We don't need this div because we're not going to create, the render function is going to do that for us. So we're just going to say, does our app render without any problems? So when we go to our test, hey, our test passed. Sanity check. I don't know. There we go. It's hard to sanity check this one because how do you break app? So yep, our test is rendering app. Oh, and let's change this to test. Okay, there we go. We've got our test passing. But remember, we want to do a little bit more than that. We wanted to test to see if the lion scoreboard is found, I guess. We're going to unit test just this specific unit right here. So we give our test the title. We pass in the callback function, and now we're going to do our assertion here. All right, so the way this assertion works is we're going to render our app, or we're rendering app because that's where the scoreboard is found. We've got the scoreboard right here, right? We're testing for this header, this lion's header. So it's found in app, that's why we're rendering app. You'll notice in the example here, let's see, imports. You'll notice in the example here that we are rendering a component and then destructuring our cheat sheet queries off of that render. So if we go back to our cheat sheet, you can see that we have a lot of queries, a lot of ways that we can query the DOM that this render function builds for different elements. So let's look at these queries here. We've got get by label text, query by label text, get all, query all, find by, find all by. So we can query the component that we're rendering by label text, we can query by placeholder text, or simply by text. So we can say get by text. So let's grab get by text off of this render function. Okay, so we have the query that we want to call. Now, we'll go back to the example. We get our query, and then we can pass in some kind of text to our query function. So what's the text we want to pass in here? Well, we're looking for this lion's header, right? So we can say, we can assert that the lion's header is on the DOM by calling get by text and passing in lions. Uh-oh. Oh, there we go. Lions scoreboard. Let's call this lions header is found. Okay. We passed that test. Yay, we're rendering. We passed our test. Let's do a sanity check, and let's say lions. Aha. So this one is now failing. Unable to find an element with the text lions. And you can see the HTML that this render function is actually building. So it actually builds out the entire component for us that we render and even console logs it when we make our assertion. Cool, so let's make that pass again. Now I'm going to talk about, for these last couple minutes, we're going to talk about one last principle with testing. We could do this, by the way, with, we have lions and tigers. So we could say tigers, and by the way, be careful. Oh, this isn't working because it's not full. I expected that to pass. That's cool that it didn't. Okay, there we go. We did our sanity check. Nice. Okay, so now we've got, we're asserting that both of these are found on the DOM. Let me talk about why we are doing these tests. And that brings us to the last principle that I want to talk about. And that is that it's better to test, it's better, let's see, let me start this way. We don't want to test implementation details. So what do I mean by that? Implementation details are things like inside our app here, if I close this down, inside our component, an implementation detail is how we built this component. If I gave you this mock-up and I said, go build this app, make it functional, there are 30 different ways that you could build this app, right? Now, testing, the whole purpose of testing is to make sure that our users are not experiencing bugs, that our software, when it gets to the browser here, is doing what we expect it to do, right? That's the whole point of testing. So most people, for a long time, we've always tested our specific implementation of a project. We were less focused on what was actually built in the end here. We were less focused on what our users see and how they interact with it. We were more focused on how we implemented the project. Now, that makes maintaining our tests and our projects actually a lot harder, because if you go build this functionality, and then I come in and I want to implement, or I want to change how some of these functions work, because how they work is an implementation detail, I have to change the function, and I have to go change the tests, even though the result of the functions are the same. If I click this button, it adds 7 points to this scoreboard. If I click this button, it adds 3 points to this scoreboard. So my implementation is different than your implementation, but now I have to write a test. I have to change the test as well. So it's harder to maintain because we've tested how that feature was implemented, not how it works for our users. So React Testing Library, if we go to guiding principles, you see this part right up here. The more your tests resemble the way your software is used, not implemented, the more confidence they can give you. And this even takes you to a tweet. I haven't read through this tweet, but here you go. So Kent C Dodds, who wrote this library, really stresses testing how your software is used instead of how your software is implemented. So let me give you a good example of this. For example, you'll notice that in my code, I have this text, lions. And I've tested that text is here in my project, right? But what happens if I change this to all capitals and then I run my test? I fail Lions header test because that's not how it was implemented in my project. But check this out. Look at what it looks like here on the DOM. It's all capitals, all capitalized. Why is that? If we inspect this, we'll see that home name transforms in CSS our text to uppercase. So let's do a quick exercise here. We'll keep this as Lions. We'll make sure that our test passes. And then someone comes and says, I want to implement this in the HTML, not through CSS. So someone comes here, takes away this, and says, all capitals Lions. Well, uh-oh, we broke a test because we're testing how this string is implemented. We're not testing what it looks like to our users. Our users don't care if this is done in HTML. Our users don't care if it's in CSS, text transform uppercase. That doesn't matter. That's an implementation detail, and we don't need to be testing. We don't need to write our tests that way. So let's write our test a better way so that we're not testing how it's implemented in our code. So what we're going to do, whenever you use get by text, we're actually going to use regex. So we're going to do a regex string here by doing backslashes around instead of these. And then we're going to do everything lowercase, and we're going to type in I. And this basically means any string that has these characters in it, casing doesn't matter. I makes casing not matter at all. And now look, we're passing all of our tests. And it doesn't matter if we come here and say, okay, we really do want CSS to be in control of this. It doesn't matter. Our tests still pass because we're not testing how it's implemented. We're not testing implementation details. We're testing that there's the text here on the screen, and it doesn't matter if it's all caps in HTML or if it's all caps, if it's capitalized in CSS. Our users don't care. All they care is that we have these strings in our test and on the DOM. So when we do our get by text assertions, we're going to write them this way. We're a little bit over time. We've got probably about 7 more minutes to finish up. So we'll run a little bit into our lunch. So I apologize for that, but let's just finish this up. We'll bust this through and finish this up. Okay, there are some gotchas with this get by text function. You'll notice in the cheat sheet that any get by function, whether it's get by label text, get by alt text, get by text, get by display value, if there's no match, it's going to throw an error and fail our test. If there's one match, then it will return. Return means it'll pass the test. If there's more than one match, it's going to fail. So let's go into here, and let's say we had one more text of Lions. So we'll say, let's change this to Lions touchdown down here. So this button is now going to say Lions. Well, we're going to fail our test because our test found multiple elements with the text Lions. Really, we're just testing what? We're testing to see if the Lions header right here is found. But our app found the Lions. Why did this not refresh? Lions touchdown button, and the Lions header. So we need to go back to our query table, and we realize that our getBy function is not going to work when we have multiple instances of that text. So let's go back to our cheat sheet. Let's find if there's more than one match, what can we do? Well, we can get all by, and then that returns an array, and we can maybe return, check to see if the first element is our header. So we could do any of those. Or maybe we can get by something else. So if you find yourself in this situation and we can't really find by label text, by placeholder text, this is just a header. We can't find by display value, by alt text, by title. We could give this a role, or we could give this a test ID. So the kind of catch-all is to give your element that you're searching for a test ID. So let's go back to our app. Let's go to the header we're trying to assert is in our DOM. And let's say data-test ID equals Lions. Oh no, something broke. Why? Man, everything that could go wrong in this lesson has, right? Oh, okay, good. So we'll try that again. Data, test ID, Lions, header. So on any element that you're trying to use in your tests, you can, if you're failing the test because there's more than one, or you're not getting a match, whatever reason, there is kind of a fallback for anything, and that is to add a data-test ID. So you should only do this if you really need to, like our specific example. So we're going to take the Lions header test ID, and instead of testing for Lions, we're going to get by test ID. And we're going to test for Lions header. So get by test ID, test for Lions header. Now our test is passing. Hey, where's my cool list? Okay, there's my list. So sanity check, it does fail if we spell it wrong. There we go. Okay, very last thing. Again, I recognize that there is so much to testing, and we've only barely scratched the surface, and that can be a little frustrating. You want to be able to jump in and know all of this and be super good at it. This gives you a really good foundation. Unit testing with functions and unit testing inside React. So the last thing I want to do is, how do we unit test a function? How do we get an isolated function, kind of like our sum function that we had earlier? How do we get that and test that in React? Well, we've got some mathematical functions going on here, right? Look at this. If we click on Lions touchdown, we add Lions score plus 7. But look down here. Let me close this. Look down here. If we click on the away touchdown, we're also adding 7 to this function. So since we have multiple things adding 7 here, let's go create outside of our component. We're going to create a const function called add touchdown, I guess. and it's going to return whatever our current score is plus 7. We know if we click on either touchdown button here, we want to add 7 to that score. So we don't have current score here yet, so let's pass in current score. And it's going to return that plus 7. So let's go down here to where we're doing plus 7. And we're going to invoke add touchdown and pass in the current score. And that will return to us line score plus 7, and it will set line score to the return value there. So we can do the same thing here where we're doing plus 7. So add touchdown. And this will return to us the current Tiger score plus 7 and set a new Tiger score to that return value. What we've done here is we've taken we've abstracted that logic into an isolated function. Well, remember at the very beginning of our lecture today, we said that a unit test tests a single unit of code in isolation. So if we can isolate a unit of code, we can easily test that unit of code. Hey, this looks like a function we could test pretty easily, right? We're exporting it already. So let's go into test. Let's import. Oh, we're already importing from our app file. So we're going to import add touchdown from app. And we're going to run a test to say that add touchdown adds 7 points to the current score. Okay, we pass in our callback function. Excuse me. We set up our actual. We set up our expected. We call add touchdown, or we say that the actual equals add touchdown and pass in a current score. So if we pass in 10, our expected value is 17. Now we use Jest. Jest is built in. So we can say expect actual dot to be expected. Expected. We open our tests. All of our tests are passing. Yay. Let's do a sanity check. Let's change this to 18. Okay. Expected 18. But we really, when we run add touchdown and pass in 10, we really receive 17. So that failed. That's good. That means our test is running correctly. We can do this. Watch this. We can say expect our actual dot not dot to be 13. This is something we might want to run for this case, right? When we click a touchdown button, we don't want it to add 3 points like it does for our field goal. So if we pass in this, we don't want it to add 3, we want it to add 7. So again, so many different ways to write these tests. So many different things so many different ways to write your React apps, so many different ways to write tests for your React apps. Finally, a little more concise, little cleaner tests. We could do all this actual and expected right inside our expect lines. So we could just say expect add touchdown when we pass in 10 to be 17. And then we could do the same thing here, dot not to be 13. So feel free to write it this way to go line by line and make sure that you're understanding the flow of testing. When you feel comfortable with this, go ahead and jump into writing them on one line like this. Okay, this is unit testing isolated JavaScript functions. Everything else down here is unit testing elements in a React app. Now, in our next testing lecture, in our next testing module, we're going to do more stuff like what's in our example here. We're going to actually fire events by clicking on a button that has the load greeting text. We're going to run asynchronous functions with Axios mocks. We're going to assert that, so if we take this for example, we could write our test in such a way that we check this number here and say when we click touchdown that it changes to 24. So we could say, we could write a test that says assert that 0 is found here. Click on this button and our test and React testing library simulates that click, and then assert that we have a new number instead of 0. We now have 7. So that's going to be our next testing module. For today, all we want to see is unit tests for both React and unit tests for our JavaScript functions. And the way we're going to do that is in this project. And you're going to build a React app. Don't worry about styling. This is more about functionality and testing. And this React app is going to be a stats keeper for baseball. So you're going to display how many balls and how many strikes are for the current batter. And here's the rules. So if a player reaches 3 strikes, so on the 3rd strike, then both balls and strikes should reset to 0. On the 4th ball, balls and strikes should reset to 0. If a hit is recorded, balls and strikes should reset to 0. If a foul ball is recorded, then you increase strikes all the way up to 2. So if you have no strikes, a foul ball makes 1 strike. With 1 strike, a foul ball makes 2 strikes. With 2 strikes, a foul has no effect. The strikes count stays at 2. Okay, so you're going to write some functions to handle all of that, and you're going to test those functions. And then you're just going to test to make sure that your app has the correct buttons and has the correct balls and strikes elements on it. So your dashboard, you're going to have a display that displays the count of balls, the count of strikes. It should be updated when the user records activities on the dashboard component. So the dashboard component has a button for a strike, for a ball, for a foul, or a hit. So you'll have 4 buttons. You'll have 2 display units. Here's the rules of how these numbers, these counts, increase or reset based on which button you click and based on their current value. Don't worry about specifying the type of hit. All we care about is that it's a hit. and there's a new batter up, so we're going to reset balls and strikes to 0. All right. Again, so sorry we went over time. There's so much to cover with testing. Let's see if you have any questions. Feel free to jump off now and go to lunch if you don't want to hang around for questions. Otherwise, we'll answer questions for the next little bit here. Okay, what is the purpose of throwing an error and then catching it in testing? How come we can't just count the log that the test failed in the first place? So yeah, again, this goes to, we can throw errors. In fact, that's what we started out doing, right? Or I guess you could console log. It doesn't matter. You could console log or you could throw an error. Either way, when we started out, that's what we were doing. We could very easily console log this rather than throw an error. So that doesn't matter. What matters is the reason we started with throwing new error is so that we could get to this point here where we built out part of Jest, and part of Jest uses try catch blocks for the test function. So in a try and catch block, you have to throw an error when the test breaks in order for it to get into this catch block. Then of course we just console log our errors at that point. But that's why we started that way, because we were going to get to this try catch block. We wanted to throw an error for our catch block here. So that's why we started that way. The reason we wanted to get to that point is to talk about automated testing. It would be really tough to build out all of these assertions manually, especially when our projects or when our functions get a little more complicated. So we've dealt with just mathematical, simple math functions. But think about what Jest gives us here. All of these, I mean, there are so many different cases that you might want to test for. So instead of, wrong one. Instead of building out our own test library here and saying, all right, so there's our to-be function. We want a to-be man function, writing out all of these different assertion functions, right? Instead of doing that, we're going to use an automated test library called Jest. So we started implementing Jest, and then we said, let's not implement everything. Let's just actually use Jest. So what's really cool about automated testing, and the reason we started with throwing errors, is every time you make a change, when your test suite is running, every time you make a change, so if we change this to lion, it's going to run your tests automatically. Notice how that didn't break? You do have to be a little bit careful with that in your tests. Let me do this. So I'll show you how this works in VS Code. So if I export this project and show in Finder, okay, it's in downloads, testing 1 starter. So if I come here and I cd to, how do I get to downloads? Oh, it's capitalized. Okay, cd downloads / let me unzip that. Testing 1 starter 1. Okay, so I'm in testing. I'm in the project we just worked on. I'm going to open that up in Visual Studio Code. Here's all of our code. We've got our app test right here. Okay, so when you're working on your project in Visual Studio, you'll cd into your project and you'll run yarn. Oh, I actually have to install everything. Okay, it's working, it's working, it's working. This is the longest yarn has ever taken for me. Something must be up with my internet. There we go. So you're gonna run yarn test. That's going to start your test runner. It's gonna run your tests. Now you'll notice it doesn't go back to your terminal. You have to press Control-C to go back. So start your tests by running yarn test. It's going to check for any file that has .test.js in it, and it's going to test any tests in your .test files. There's a lot of different things you can run. You can do here. You can hit enter to run all your tests, or if we just change something, let's change this to, where is our scoreboard? Let's see, there it is. If we change this to the Bears and save it, you'll notice that our tests are running again. So our tests run. Oh, we got an error. One failed. We got 3 passed, but 1 failed. So we go up and see that Tiger's header is failed because we changed the name to Bears. So this is automated testing. This runs our tests for us, and usually when you're working on a team, you usually actually have your test runner up and running while you're building, while you're working on components that have already been tested. You're gonna be running your test runner while you're building and fixing tests and fixing code along the way. So great question, led to lots of good stuff there. All right, what about testing your add field goal function adds the correct amount of points to scoreboard? Yeah, do it. That would be my next step, is adding a field goal. So we tested adding touchdown. My next step would be to abstracting this into its own function and testing that. Absolutely. And that's what you're going to do a lot of today. You're going to abstract the math functions out, and they're going to be complicated, a lot more complicated than just a simple sum or subtract function. So you're going to have to write some good tests for it. But yeah, this is basically what you're going to be doing today. Is test part of Jest or React Testing Library? Test is part of Jest, which is brought in by React Testing Library. Can you give an example of something rendered on a virtual DOM that would not pass a test? If you see something rendering, does that not automatically mean it passed any render test because it's on the DOM? Yeah. So it's what this first test does, and I do this for all my components. This just tells me, this gives me an early hint that something is wrong with my function here before I see an error in the browser. So the reason we want to do this is sometimes you have components that are nested inside other components that there's some conditional rendering going on. So it's not always, if you change something in that parent component that breaks the child component, but that child component isn't rendered on the DOM while you're testing what you're doing with some other component, some other child component, then you won't see that what you're doing is actually breaking that child component. So this is always good, especially as you start integrating lots of different components together and testing how things work together. So this is more for advanced testing later on. But yeah, really great point. In the simplest form, yeah, we would see the browser break for app before we really see this test probably. Okay, so do I yarn add capital D testing library, then create React app? No, you're going to create React app and then add the React testing library to your React app. So at testing library / React gets added to create React app. On today's project, should we be using class components or hooks? Okay. Hooks are fine. Again, try to practice with class components when you can, when you want to, because you will be using class components when you get hired. There will be legacy code with class components. You want to have practice with it. Is Yarn add testing library React the same as ARN? This is different. This is deprecated. So you want to do at testing library / React. And don't forget the -D, which adds it as a dev dependency rather than a dependency. The difference is when you have different environments, when you've got your production environment and your development environment, all the code in this library won't be added to the production code that you push live. So it just makes it so your production library is a little bit, or your production code is a little slimmer, doesn't have all of this code brought in with it. So yeah, the testing stuff you want as a dev dependency, you do yarn add /d and then add this part here. Not this part. This one's deprecated. Add this one. On that note, yes, you can copy paste dependencies from the dependencies block into dev dependencies. Excuse me. And yeah, that's just fine. It's the same thing. It just is a different. This is going to be a bad example because we brought this down from Code Sandbox, and Code Sandbox doesn't do dev dependencies. So at testing library / React is in dependencies. So yeah, just cut that there to dev dependencies, and there you go. Now it's a dev dependency. All right, awesome. Have a wonderful day. Again, sorry for the long lesson. Good luck on your projects tomorrow, and I will see you tomorrow afternoon for Q&A.